Hi, and welcome to this flipped instructional session. Today we're going to talk about lessons 1.04 to 1.08 in Middle School Earth Science Semester B. We're just going to talk about the main points from each of these lessons as we prepare to complete the 1.10 graded assignment, Forecast Like a Meteorologist. All of this is important background information for that lesson. So first we're going to talk about air masses. Air masses are often referred to by forecasters by the force of their air pressure on the Earth's surface. A dense continental air mass is called a high. So anywhere you see these H's on the map, that would be a high, where there is an area of dry air that's pushing down on the Earth. A less dense maritime air mass is called a low. So a low is a low pressure area of humid air, such as these L's here on the map. So from lesson 4, we're going to compare these low pressure systems to high pressure systems. If you're taking notes using the note-taking guide, this table is from lesson 4. So a low pressure system, as I just mentioned on the previous slide, is less dense. The air right here, where the L is, in the middle of the low pressure system is less dense than the air around it, so it floats upwards. And as I mentioned previously, that this air is filled with moisture. So that humidity is what is caused by the moisture. So the humidity is very high because as that wet air rises, it begins to cool. The water vapor in the air begins to condense. Condense being that water turning from a gas to a liquid. It is very cloudy around a low pressure system usually because as that water vapor that we just mentioned condenses, it forms clouds. Because there's clouds, there's frequently precipitation, and a low pressure system is windy because as the air rises up, it creates wind. So as you can see, a low pressure system is going to be rainy with clouds, less dense, and oftentimes precipitation. The opposite happens in a high pressure system. In a high pressure system, the air is more dense. It is dry and cool, so it sinks. And that as that air starts to sink, it becomes warmer. Because this is dry air, there is not a lot of humidity. The humidity is low. The clouds, it is not likely because, again, that air is sinking and not rising and condensing. Precipitation is also not likely because, again, the air is sinking and that sinking air might only produce light winds, where a low pressure system, this rising, is going to produce higher winds. So when you draw your map, eventually in lesson 1.10, you will have to add high and low pressure systems onto your map, such as the ones shown in this picture. So as you can see, the low pressure system, there's all of this rain and storms nearby it, whereas the high pressure system, it is clear around those systems. All right, so now we're going to move into lesson 7, which is air masses. So again, this is from the note-taking guide. If you are following along on your note-taking guide, you can use this right here to take notes. So to define an air mass is a large body of air with similar pressure, temperature, and humidity. So we kind of started talking about these when we were talking about highs and lows. So the different words that are used to refer to an air mass are tropical, polar, maritime, and continental. And it'll be a combination of two of these words that is used to describe an air mass. Tropical meaning warm. As you can see, they're coming down here from where it's warm. Polar, referring to the North or South Pole, where it's quite cold. So there's air masses are shown in blue here because they are cold. Maritime, relating to the sea. So mar is a prefix for sea. So these air masses are moist and coming from over the ocean, maritime polar and maritime tropical. Then we have continental, which are forming over land. So as you can see, it's a combination of two of these words that forms each air mass. Continental polar forms over land and cold. Maritime tropical forms over the sea and warm. So these are just more details about what I mentioned. Maritime tropical form over water and are warm. They are humid and bring rainy or muggy weather, but they eventually dry out and become a continental air mass. The other type of warm air mass is a continental tropical. So this forms over land. For the United States, it forms down over Mexico and is warm. That dry air is denser than the humid air, and as we talked about a few slides ago, it has a higher air pressure because that high density air wants to sink. Then we have cold air masses. Maritime polar air masses are cold and humid. They are forming over the oceans near the Arctic for the United States. A continental polar air is cold and dry, and they're forming up over Canada for the United States. And then last we have Arctic air, the extremely coldest, driest air mass. So which of these three cold air masses do you think has the greatest pressure? The answer would actually be the Arctic air because it is the coldest, the densest, and therefore the heaviest. Plus it is dry. All right, so then finally lesson 8 talks about weather fronts. And this is another thing that you're going to be drawing on your map as part of the 1.10 assignment. So we're going to talk about warm, cold, stationary, and occluded fronts. So each front is formed when an air masses collide. So air is and always will be a fluid substance. It's constantly moving. If you wave your hands around in the air right now, you're moving air around. If two masses with different temperatures or humidity levels meet, they do not immediately mix or blend. Instead, a line or boundary forms between them. This boundary is called a front. You will often hear fronts being discussed in weather forecasts because it is at a front that most of the really interesting weather happens. So first we have a warm front. This is when warm, light air runs into a cooler, cold, dense air mass. Because warm air is less dense than cold air, it rises up over the cold air mass. That's what you can see right here, the warm air rising up over the cold air. And this typically forms light rain or snow as that warm air rises, cools, and condenses. Next, we have cold fronts. In a cold front, now instead of warm air pushing into a cold air mass, we have cold air pushing into a warm air mass. So this is a very fast-moving front and very severe weather frequently. As that cold air pushes in, the warm air is forced upward really quickly, and that quick upward force can form rain, snow, hail, sleet, and this is even what forms tornadoes and lightning storms. Next, we have a stationary front, and as the name implies, it is stationary or not moving very quickly. So a front between warm and cold air masses that is moving very slowly or not at all. So these two air masses meet, and instead of one going above another, they just kind of sit next to each other. So gray skies, rain, or snowy weather that may last a very long time occurs at a stationary front. Winds may blow as these two fronts try to meet each other. Finally, we have an occluded front. This front occurs, it's very interesting, it's actually three air masses when warm air is wedged upwards between two cold fronts. There's still a clear division between the cold air, the cooler air, and the warm air. So the warm air is forced upwards while these two cold air masses meet down below. As that warm air is forced upward, it cools, and that water vapor in the air condenses, and we again get light to heavy precipitation and strong winds. So that is all we have for today. Again, that was a quick review of lessons 1.04 through 1.08 in preparation to complete the 1.10 graded assignment, Forecast Like a Meteorologist. I hope to see you at the flipped follow-up. Have a great day. Thank you. Bye.